Hello, dear students. Today we are going to discuss another topic on the distribution reservoir. We have been studying distribution reservoir for some time now. We have to understand what are the types of distribution reservoir that are used in the water supply scheme. There are basically three types of distribution reservoir which are used in the water supply scheme. The number one are the surface reservoir, the other one are the elevated reservoir, and the third ones are the standpipes. Right. So the basic use of distribution reservoir is the same in all the types. It is to supply the water with the least possible pumping cost, right? But the use of different type of distribution reservoir is dependent on various factors like the location or the area which is to be served, the elevation which is to be served, and the distance up to which the water supply scheme has to working. That is, the tail end of the scheme should not be too far from the distribution system. So what are the types of reservoir that we are going to use is the number one is the distribution reservoir, is the surface reservoir. The surface reservoir can be circular or rectangular in shape. These reservoirs are constructed below the ground surface or just on the ground surface. As you can see in the figure, a reservoir which is rectangular in shape is being provided, and it is provided 10 centimeter water pipe, 10 centimeter just above the bottom of the surface, and there is inlet which is in the top portion of the in the surface reservoir, and the outlet is in the bottom portion. When the water is stored for a longer period of time, if there is some amount of debris or some amount of organic vegetation or something, and that can be any material which is not to be expected in the water supply scheme, that material will settle out on its own, and for that purpose in the bottom of the tank a washout pipe is provided, which is for the cleaning purpose of the tank, and it is used for the cleaning purpose, and it is provided in the bottom of the tank. The outlet pipe is just above the washout pipe, which is being used for water supplying to the various portion of the locality which is serving. Also there is a ventilating pipe. This is for free air circulation, so that the air pressure does not form, air pockets do not form, right? On the top of the tank there is a manhole which is used for cleaning purposes and washing purposes of the tank. The periodic maintenance of any type of reservoir is mandatory, and for that purpose the manholes are provided. So this is an line of a surface reservoir, right? The next type of reservoir is the one that you have most probably seen all over the city, which are the elevated reservoir. In Hindi you can see it pani ki tanki, that is provided at various sections of the locality. That is, elevated reservoir is a type of reservoir which is connected to a surface reservoir. The water from the surface reservoir is pumped to an elevated reservoir which is having a larger amount of capacity, and this is for the purpose that the water should be supplied under the influence of the gravity. The more the pumping required, the more would be the operation cost of a water supply scheme. So we have to keep the operational cost of a water supply scheme to be minimum. That is why we have to use low amount of pumps for the water supplying scheme. For that purpose, and also for to be used in the case of emergency in times of pump failure or any mechanical failure, the elevated reservoirs serve the purpose very efficiently, right? These may be constructed of stone masonry or reinforced concrete or steel. These reservoirs may be rectangular, circular or elliptical in shape. In the same way, the ventilators are provided at the top, and also there is a manhole provided at the top. In the manhole, since this is a large section of the tank, the depth of water in the tank is quite high. That is why the manhole, just near the manhole, a ladder is provided within the tank's capacity, or steps are provided, so that a person who is expected to clean this system can go to the bottom of the tank, right? There is also a level indicator which shows the amount of water present in the tank, so that the tank is replenished in case when the water is being supplied, right? There is an inlet pipe which uses a pump connected to a surface reservoir to send the water inside the elevated reservoir. That is, at least one pump system is required from the surface elevator to the elevated reservoir, so that the water can be stored at a certain height. There is also an overflow pipe on the top of the tank, because if there is a larger amount of water being continuously supplied into the system, then there may be chances that the amount, if not manually operated or if not automatically operated, the water can spill over the top, so that the system does not get affected due to the overflowing condition. That is why it becomes very important to provide an overflow pipe towards the top of the tank, so that any amount of excess water can be discharged from it, right? Also, there are washout pipe on the bottom of the tank. This is for the cleaning purpose only. And there is a outlet pipe, which is for taking the water from the elevated reservoir to the various localities and various sections of the community that it is serving. There is also a ladder system that you have commonly seen, so that the top of the reservoir can be reached. So every elevated reservoir will always come with a ladder system, right? So this is a figure of an elevated reservoir that you can see on the screen. This is very common, and a surface reservoir can consist of n number of elevated reservoir. That is, it is not necessary for one surface reservoir to supply water to a single elevated reservoir. There can be multiple elevated reservoir for the same purpose, that is to supply water to a certain locality. So there is in every locality there is an elevated reservoir always there, right? Next is the standpipes. Standpipes are normally used when the construction of a surface reservoir would not provide sufficient head. A standpipe is a vertical cylindrical tank resting just above the ground. The diameter of a standpipe varies 8 meter to 12 meter, and its height varies from 15 meter to 30 meter. A standpipe can be made of steel or RCC. It consists of an inlet pipe and overflow pipe, a washout pipe, similarly to the elevated reservoir, but they are made near to the surface as compared to the elevated reservoir, and have the same purpose, is to flow of water should be under the influence of gravity. Okay. Next, you can see the figure of this. You can easily understand where washout pipe and the outlet pipes are provided from the bottom, and with the mean water level, and there is a manhole over the top. So this is basically very similar to the elevated reservoir. Next topic that we have to understand is the location of distribution reservoir. The only point that is of importance in the location of distribution reservoir is that the distribution reservoir should ideally be centrally located or as close as possible to the areas to the serve, because you understand, you have studied the pipe losses. You understand that as the length of the pipe keeps on increases, the head losses due to friction and other losses like bend losses and other losses which cannot be controlled keep on increases. So to avoid the water losses or loss of head in the pipe system, we try to locate the distribution reservoir as centrally as possible. If the centrally is not provided, it should be provided near to the locality where it is to be serving, right? You can see the distribution reservoir here is centrally located, so there is less pumping required, and there is also not much losses due to friction. But in case the reservoir is provided outside the supply system or outside the scheme of where the water is to be supplied, the pressure head or the hydraulic gradient line where the places are near to the tank is more, but as far as we go in the water supply scheme, the tail end does get very low pressure, or at times air pockets are formed and the pressure becomes very low. So this is very important to locate the reservoir ideally in the central position. Okay, thank you so much.